So we've done some working with lists, and let's look at some other ways that we can work with lists that make them really useful to work with. So here's an example. I've got 4 names in a list called names, and I want to check to see if someone is in a list. So I'm looking for if a name is in a list. Well, this is actually pretty easy to do. I can say if and then give a name in my list name, and then I have an option. And the in command is just a Boolean variable. It returns a true or false, so we can use it in something like a if-else statement. This works very, very efficiently for us. However, you might have a question mark about this. For example, Jim is in all lowercase in our if statement, but in our list, he's capitalized. So let's take a quick look and see how this would work. So I'm going to run my file, and it comes up that this name was not found. And that's because it didn't match exactly. So let's go and make a quick modification. And let's run this file again. Now you notice that it finds him. So if you're looking at this example and you saw that Jim was not capitalized, you'll note that it has to be capitalized in order to match. And that's just an interesting thing. Now you might say, well, why would you know? You have your list there. Well, we can append data to a list and add it through a lot of other methods. So we've got to keep an ability to be able to check to see if an item is already in there or if it needs to be added in. Now we mentioned looking for a file to see if an example exists. Well, here's a perfect example. I have a list of names and I'm going to delete some names. You might go, why would I want to delete some names? Well, every once in a while I need to remove an element. And so in this case, I'm using the delete command. And it's a function that takes in an element, a specific element with an index. So we're going to go and run this file. And you notice that I have a list of 4 names. And then after I do the delete command, I go and print out my list again. I see a list of only 3 names. So this is one example of why we want to be able to check for in to see if they exist. Now here's an example. I have a list of numbers. They're not in order. And I could have got to this list either from the way people were entering in numbers and just give me values, maybe from a file, or I'm going to use the min and max functions in order to determine what the largest and smallest values are. Min, and then I pass in my list, will return the smallest value. Max, if I then pass in my list, will return the largest value. You'll see that even though that the smallest and largest are not the first or last numbers, it can go through and find that information very quickly. Now, this is very helpful when our data is not sorted, as in this case. However, we will look at in just a few minutes how we can use the sort function to sort out this information and maybe make it a little bit easier for us to look up and just look at data and see. But until then, using the min and max function is very beneficial for us. So here are an example of some names. I just have 4 names in a list, and there's just a list of strings. I'm going to print that out. Then I'm going to append a name and print it out. And what you see when you run this is that appending a name adds a name to the very end of my list. And this is very important to know and how to work with this, as it lets me see where my file is coming. It doesn't put them in any type of order. It just is going to put it at the end whenever I append data. So we've now seen how to delete data and how to append data. Once we do some appending and working with it, there's something else that we need to sometimes wonder about, and that is, where does my data exist? This is especially true if it might have been moving because we added and deleted data. So here's an example where I'm going to get the index for an element. And it basically goes and does a search to find out, does this element exist? And if so, it's going to print that out. We run this again and notice that it finds it at index 1. Now, you may be looking and saying, well, wait a second. Heather is the second element. Remember that my list start at element 0, my index 0. Therefore, the first element is 0. The second one is index 1, and it moves on. This is very important to remember whenever we're working with lists. But because it's important to remember where an index starts, we'll see another example in this particular case. Here I have a list of songs. I have 3 songs, and I'm going to print out that list. Then I want to insert. And the insert works different than the append. The append method always puts the element at the end of my list. Insert allows me to insert in the middle of my list, anywhere in my list, and that includes the very beginning and the very end. So let's take a quick look. So my first example, I see my first 3 songs. On line 3, when I say insert 0, I'm inserting at element 0. That means that now it's going to be the first element in my list. On line 4, I insert at element 3. So if I go 0, 1, 2, 3, notice that it remembers because I put an element first with help, it inserts it appropriately. It's not based upon my original list. That list has changed. And so it gets inserted not as my last element, but as my next to last element. Something to keep in mind when working with lists. They are subject to change. Therefore, we have to keep an idea of where our elements are when we're inserting elements. One last thing I want to look at is what we can do with a list. So we've looked at adding elements both by appending and insert. We've looked at deleting elements, but now I want to look at a couple other functions. And this is going to be our sort. And I have 2 different lists. In my first list, songs, I have a list of songs out there, what we just saw, and I want to sort them. I also have 2 separate lists of numbers. I'm going to concatenate these together using the plus operator, and then I'm going to sort them. And we're going to see a difference between 2 different sorted lists because they're different types of lists. So here we call our file. And if I look at my list, you'll notice that now they're in different order. Each song is in a different place because it was sorted alphabetically. And my numbers numerically are also in a different order. So the fact that Python's smart enough to look at the types of data and be able to sort it appropriately is very, very important to us. And we can see that it's sorting it based upon what type of data is in our list. And that gives us just a little more functionality with the functions that Python provides for us in working with lists.